Hi, welcome to Digital with Darren. I have a master's degree in physics at Imperial College London and graduated in 1997. I designed satellites at Matra Marconi Space, and I spent 20 years as a quantitative trader on proprietary and flow trading desks in the City of London. Right, so as you can see here on the screen, I wonder if I can resize it. I've just made a Python game, and this is what I'm actually going to show you. I've called it Sky Dodge. All it basically is you've got this little red ship that is flying around the place over there, if you can see it with my arrow, and you can move the little red ship around, and if you crash it into the various other ships, then they will disappear, depending on if it's the right ship to crash into. So we'll see. Let's try and crash into this one over here. There we go, it's disappeared. Let's see if we can crash into that one. That's not the one, so it's got to be the other one. And here we go, crash into it. Bang. And the final one, just fly into it. And then the game closes. So I'm going to show you how I've made this game, and there are different ways of making games. There's different modules that are available. The module that I've chosen to use is called pyGame. I've used TK Inter, although I haven't made a game on TK Inter, and I've also used Turtle Graphics, which is a 30-year-old package, if not 40 years old, and that's actually quite good as well for making games. But the game that I'm going to make here at the moment, which is Sky Dodge, is going to use the module called pyGame. The first thing I do is do some of the imports. So I import pyGame. I also import a module called random, and that's for the purpose of generating random numbers, which is used for positioning the items on the screen, the items being the various rockets or any other image that the user wants to create and upload onto the screen. And the one other module, which is the module at the top here, OS, is for the operating system. Now, the first thing that I do is I go through, and this is what the user has to do, import pygame locals for easier access to the key coordinates. And these are just basically for when the user presses the up arrow, K up, down arrow, left arrow, right arrow. There's even one for the escape key. The escape key on my keyboard, and most keyboards, is the top left-hand corner. Then there's something called key down, which is actually when the user has pressed the key, so any of the keys is down. So when key down, then any of the other ones above can be done, and there's also a quit one at the end. We then go on for defining a size for the screen. So it's just two variables. One variable is for the width, one variable is for the height. At this point in time, I've just set it to, you can choose whatever you want to set it to. I've just set it so that it's slightly wider than it is taller. It's 800 pixels wide by 800 pixels wide by 500 pixels high. The next part is a variable which is FPS, which stands for frames per second, and that's actually for the loop speed. You'll see where that's implemented, but basically this is 30 frames per second. So it's a refresh of the screen that's fast enough so that the user can see a continuing moving image. Again, another thing to do is define some colors, and these are just another more variables. So, and if you notice, all of these definitions are in bold, not bold, in capitals, and that's something that's just done in Python. It could have been done in lowercase. I could have typed in red in lowercase, but it's in uppercase. And the colors are defined as, they're not tuples, but triples. There's three colors: red, green, and blue. As you can see here, red is the first value, and it goes from 0 to 255, so there's 256 variable possibilities for each of the colors. So red is 0 to 250. The red is the first one, which goes from 0 to 255. Green again, so you switch off the reds by setting 0, and then switch on the greens to its maximum, and then switch off the blues, so it's red, green and blue. And then we can see also finally for the blue one, we've switched off the red and the green, which are the first two, and the blue we've set to 255. I also set two other ones, which is black. Black is nothing, nothing, and nothing. So there's no red at all, no green, and no blue. That's black for the definitions of colours, at least in Python, but it's in many other languages too. And conversely, white is the maximum colours of red, green, and blue. So I just set them to 255 each. So red is 255, green is 255, and blue is 255. And that actually makes white. And again, that's common for all programming language, but we are using Python here. And there's other colours as well, and I've set, well, I've done a dark red below, but I don't actually use it anywhere in the code. But again, you can see for the dark red, and this is just for the purpose of it, I haven't set the red to 255, but I've set the red to something, and then I set the green and the blues to not to 0, so that they're ruled out, and then it's not as bright as a red as in the red above, because it's not up to 255, so it's a dimmer sort of red. But this one does get used, and you will see it. So this isn't as blue as the blue here. This is, so I've called it dark blue, and the blue component of it is the largest of the components of the red, green, and blue. I set that to 150, and the red and green just to have some extra tiny little things that you can't really see, but I've set them to 25 each. So that's dark blue, and that does actually get used in the code, which I will set somewhere as a background effectively. So we've got a darkish background. The other thing we do is we set up folders which contain the assets. And the assets are images and sounds. So all we do here, and this is a purpose of importing the OS module, which is here. And the purpose of it is that we can call the file names, and we can, or the folder names where the files might be contained. So we've got one folder which is called IMG, which just stands for image. It's just a shortened version of image, and that is a folder containing the images. And another one, SND, which is shorthand for sound, which is a folder containing the sounds. There's only one sound I've actually used in here, but it's just for the purpose of showing that you can have images and sounds in your game as well. And actually, really, I should be putting in a proper sound so that there's some music for the background, but I don't do that. All I've used at this point in time is a little blip for when the space rockets crash. The next thing to do in pyGame, and this is just from the documentation, is to initialize pyGame, and it's as simple as just typing pyGame init. So pygame dot, and then there's lots of different functions, and this is to initialize init like that, and that's all it does, and it initializes all pyGame modules. That's all that does. The next part is to set a caption at the top of the game. So when you saw the game actually running, just like we've got a caption at the top of this, at the top of Visual Studio Code here, and in this particular caption it's going to say the name of the file that we've got. Well, it's just nice to have something that says Sky Dodge Game, and I've used my initials DL, Sky Dodge Game, and that's going to be in the caption at the top of the bar just above the game. The next game is to import the sounds that are going to be used, and again, like we can see here, so one sound is a thwack sound, so I've just called it thwack01, and another one is thwack02. And the way that we call sounds is we do pygame.mixer.sound, and then we're going to call the file where it is. And again, we use the operating system module because we're going to join the folder which is this sound folder, and then we're going to join that to the file name so that we can call the file by its folder / file name. And we do that for both of the different sounds, and if we had any other sounds, we'd also load all of those as well. They're called the assets, and also in the assets are the images as well. So one thing that we've done right at the beginning is we've loaded the sounds. And we can play it. And this is how we play a sound. So just when we've loaded the sound, I just set this line here and it just makes that sound. So when the game actually starts, it'll go like twuk or whatever it is for that twack sound. The next thing we do is I've just created some messages for the users so that the users or the players can see a message on a screen. Again, we just define a font and we use the pyGame module, pygame.font.system font, and then we choose one of the fonts from the system. I've just used a monospace 12 font, which is sufficient, and it's just something that, you know, where we write our text in it. And the initial text I've put in there is sky dodge text, and what we have to do is we have to call it as true, otherwise it won't show. And then we've got to put a foreground. So I've called that white for the foreground and then a background black, just so that there's white text on the black background. And we've used a dark blue background for the entire base of the image. So we've just got a dark blue background and then a black background where white text is written on. That's all, so that we can just see it nicely. And we position the text boxes. And I've chosen here to do width times by 0.6. So it's like roughly it starts halfway across the screen according to the width, 60%. And the width of the screen is, it starts from the left hand side. So you've got like pixel 0 here, and then you might have pixel like 100 across here, next one, and then 200 as we go along. And then we'd have 300, 400. 500 and so forth. We set it to, we'd have 600, 700, and we've set it to 800 wide, so our screen will be that wide. And so 600 is somewhere starting about, or 60% of our screen width. So in fact, I'll calculate that. So it's 60%, so it's 0.6 times by 800, so it's about 480 pixels along. So we'd start about there. So if this was the start of our screen here, where I've marked the X, and this is at the end of our screen over here where I mark the X, then 480, so the writing starts somewhere about here. And the same thing for the height. It's actually quite close to the top of the screen, so we're going to do, so for the height, it starts at the top of the screen, and the pixel counts down for the height. So it starts at 0, and then as we go, it would be 100, 200, 300, 400, and 500. Remember, we defined the height just further up here at 500. And it's just the way that pyGame, the way that its particular applet that's launched counts its pixels from. So if we go 0, 0, it's the top left hand corner that we're referring to, and where we go 800, 500, it means go 800 across. So we go 800 across this way, we just keep going across like that, and we get to 800 and then 500 down. So that's like the bottom right far corner here. So this would be 800, 500, and this pixel here at the top would be 0, 0. So that's just the dimensions of the screen. That's how it looks. So if we do height times by 0.05 here, and also height times by 0.07, we're basically saying do the height pretty damn close to the top. So we take 800 and we times it by 0.05, 800 times 0.05, and that's like 40 pixels high. So we're basically writing something on our screen about here. X, 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 and then a line just below it, just like that. And that's what's going to look. 2 text lines will be written on the screen, just like that. The next thing to do is to create the player classes, the classes that are to construct the actual sprites, is what they actually call them in gaming terms. So what I do here is one for the player itself, and we just define a class the usual way. So this is just the text string or the doc string that goes in the class, so that if one was to hover over it, I believe it says here class for player sprite. It will just say whatever's in the doc string up at the top here. So the player, and we initialize it. All classes are initialized usually, and the initialization here is to put the image in, and we do that. Well, first of all, I've just created here, if you can see, image name, and I've just made an array of images. The actual image that I'm particularly going to use in this game is one called image name 2. Remember that arrays are, the first element of the array is 0, so this is image name 0, and this is image name 1, and this is image name 2. So I'm going to use this file called dl-rocket-red-01.png, which is just the file name for a red rocket, effectively, that I've created. And the way that we do it here in Python is, so we do self, and self just refers to the class itself, and then we do .image, and so that's the actual image. So self.image is equal to, and then we're going to set pygame.image.load, and that's how we do it in Python, in pygame in Python, which is right here, pygame.image.load. And then what we're going to load is the actual file name with the full path, though, remembering. So it's the file name, and the way that we do that is os operating system.path.join, and we're going to join the image folder to the image name, and the image name we've just said is dl-rocket-red-01.png, and the folder we declared that above, which is here, image folder, and that is just os.path.join, which is just the game folder, which is this current folder, and then it's just one subfolder down from there called image. So it's this folder /image, and then / and then the file name. So that's what all of these os.path.joins do. And when we load the image in pygame, so we use pygame.image.load, and I've actually seen this on other YouTube videos as well. If we don't do .convert, then the rendering is much slower, because the image is attempted to be drawn out, or the pygame attempts to draw the image out pixel by pixel, so it's a much slower process. Whereas if this .convert is done, then it makes the game more efficient in terms of the actual drawing and rendering of it. The other thing that we do is we've got something here which is image.setColorKey, and then here I've specified a color, and I specified white. And the reason why is, if we draw an image and the images that I drew are all rockets on white backgrounds, but we don't actually want white boxes behind our rocket images on the dark screen. So we don't want white boxes flying around the screen with little spaceships in them. So this set color key actually sets whatever the background color is, or whatever color you don't want to show, it sets that to invisible, effectively. So in this particular case, we've got these white boxes. I could have drawn space rockets on black backgrounds or blue backgrounds, and then I've had to set this value to black or blue and so forth to get rid of the background, so we only have the rocket shape. The next part is to get the actual and it's called a rectangle, and effectively all of the surfaces that are created are rectangles, and the rectangle here, or we use the getRect function, which is which gets the value of the rectangle. So it gets the top left-hand corner, which is north of the or the position of the left-hand corner, wherever that might be, the XY coordinate of it. And then the rectangle is also defined by a width. So it starts at X across, and it has some kind of width W, and it's also got a height. So a rectangle might look like something like this. It will be, it will have its top left being X, Y, and then it will also have a width W, say for example, and a height H. And so we could define a rectangle like X, comma, Y, which is the top left, comma, how wide we want it to be, and how high, remember tall going downwards, that we want it to be. So that's what it might actually look, or that's actually what it actually is that we're describing, or we're calling back in this particular case. And we can set the center of the rectangle, and we can give it the how far across we want it to be and how high up. Now in this particular case, I've just set the rectangle to be roughly a quarter of the way across the screen. So it's the width of the screen. Remember, width was the width of the screen, and we set that to be 800 pixels wide. So quarter of 800 is 0.25 times by 800, which should be 200. Yeah, it's 200. It'll start at 200 pixels across, and height over 2, we set that to be 500 high, so it will be 250 high. If I didn't set the ints, so converting this floating number into an integer would come up with error messages. pyGame would actually do the conversions for us, but it would just show us down in the terminal here. If we were actually running it in this terminal bit, it'll come up with some sort of error messages saying that it's converted floats into integers for the pyGame to run. The other variables that are set are the speed, and in this particular case, I've set an X speed, which is a horizontal speed, and a Y speed. I've set that to 0, so there's no actual Y velocity. There is an X velocity. It's 4, which means it's 4 going in that direction. It's going that way rather than the other way. It means it's plus 4. It's incrementing by 4. It will be incrementing by 4 each time. We'll see that just slightly below. So at the initializations, once we've completed the initializations, we create another function, and that's for the update. And we update self. Remember, self is the actual class itself, which is player in this particular case. So we do update self, and we set this rect, and we set the X component of the rect to increase by self.xSpeed. So in this particular case, the X speed is initially set to 4. So X just keeps on increasing. That's what this plus equals is. Is increasing by the value of self speed, which is of value 4. So it's increasing by 4, and likewise the Y value is changing by Y speed, which at this point we've set to 0. We could set it to a number so it's moving vertically as well as horizontally, but we're just initializing the game. We then look at the boundary conditions, because we don't want our rocket, or we want to be able to deal with the rocket if it gets to the edge of the screen. So we do this by looking at the bottom of the rectangle. Remember that the rectangle has its it has a X and Y coordinate, and it's got other positions on it. So dot bottom represents the lower part of the rectangle. So if you've got a rectangle that's, you know, off position, it's got an X position of say 10 and a Y position of 10, but it's also got a height of say 20, then the bottom will be 10 plus the 20, which is 30, so it'll be 30 down. And we want to make sure that the bottom of the of the spaceship, if it gets too close to what is known as height, which is the height of the screen, less than 10, so a couple of pixels, 10 pixels above the bottom of the height of the screen, if our space rockets get too close to the bottom, then it's going to bounce off the bottom. And how we bounce it off the bottom is we just set the y speed equal to -3, and that means that if it was going downwards and going down to hit the bottom, the number would be increasing. Remember, going downwards is increasing in value because we start from 0 at the top and we go down to 500 at the bottom. So what if we've hit that bottom, we want it to turn that number into a negative number so that we can move back upwards. So we can go from 500 to 497, which is the next step, -3, and then 494, and then 491, and so forth, and we'd be moving back upwards towards the 0 level, so i.e. to the top of the screen. Likewise, we're going to do this for the top. If we're too close to the top, then we want to set our speed to be positive. So that means we had a negative speed, we press the up arrow key, and our net speed became was more and more negative, and we hit the top of the screen, and we want to just bounce it off to either set the speed equal to +1, that'll bounce it off. And likewise, if we go off the left hand side of the screen, we want the space rocket to be to come back onto the right hand side. So what we do there is, if self.rect.left is greater than the width, so if we've gone over 800, which was the width of the screen, then we set the rectangle, the right hand component of the rectangle, to be equal to 0. So we've moved it back over to the right hand side of the screen, and it starts at the beginning. That's all that is. The next thing we do is pretty much exactly the same, and if I hover over it, you can see again, class for enemy sprite. We're creating a class for the enemy sprite. Now, the class for the player, we're actually only going to call it once. You'll see that when you call a class once, it's called a singleton. But for the enemy, we're going to call it multiple times. We're going to make a few enemies. You will see that down below. We actually set up an array down below. We will get to it, and we set the number of enemies to be 5. We can set it to any number, and we do roughly the same thing, which is we go through this initialization, and we do the pygame.sprite initialization. So we initialize a sprite, and we again here I've got image name. And this time it's a whole bunch of different images. And this is actually, I've set a rocket, an orange rocket pointing upwards, and a green rocket pointing upwards, and then a pink one, and then a cyan one, and then a brown one. So there's one, 2, 3, 4, and 5 different colored rockets. And this is actually the first time as well. So there's 5 rockets that are defined in an array, and so there'll be the 5 enemies effectively. And for each one of them, we're going to choose a random color or a random image. And each image, remember, is one of these colors. So we've got the orange one, we've got the green one, we've got a pink one, a cyan one, and a brown one. And we do exactly the same thing. They're stored in our file in the img folder, and the img folder, if we remember, was set from above. And this time we use this random function here, and we do random.choice. And you can see here, if I hover over it, choose a random element from a non-empty sequence. And here is our non-empty sequence. It's an element of 5 things. It's going to choose one of these rockets randomly. And then we do .convert, which renders it nicely. And again, we do the set color key white, because the backgrounds were all white on these particular rockets, and we don't want to see the white squares everywhere. And then we do the image.getRect to get the rectangle of the image. And then we do the center. We define the center of it. At this point in time, we just define all of the centers to be anywhere 95% away across the screen, and half of the height. But actually, we're going to randomly set them later on, so it doesn't really matter what these are. just set any value for that, because these are going to be overwritten afterwards, but just to give them some initialization center. And then we do a size as well, although I don't actually use a size, so I believe that this could be ignored or commented out, this bit of code here, but I will leave it uncommented, just to leave it in there because the code's working. And the next thing to do is the speed, and I could have just set all of the speeds to be equal to 0, but it's quite nice to make them move. And we're moving, in order to move, we can, if we want to move the X speed, so we're choosing, I don't want to move these things too fast, otherwise we won't be able to kind of like catch them up. It'll be a bit difficult to sort of like create the collisions that we need in order to reduce the game down and get to the end of the game. But randomly we move between plus and -2. So it's a slow movement. Remember, if it's -2, it's moving to the left-hand side. It's going down in value on the X. And if it's +2, it's moving towards the right hand side of the screen. And if it was randomly set to 0, that'd be stationary. And if it was -1, it'd be moving slightly slower than -2. And if it was +1, it'd be moving slightly to the right hand side, but not as fast as +2. And the same thing for up and down on the Y speeds. I've just set it from between -2 to +2. So again, we've got some slow movement, some slow random movement of the rockets, either upwards or downwards. Or if it was set to 0, then they wouldn't be moving on that particular axis. So if the if Y speed randomly happened to be 0, and there's only 5 choices: -2, -1, 0, 1, and 2. And they're all of the choices, and if it happened to be 0, then it wouldn't have been moving vertically, that's all. And then again, we have this function for the update of this particular class, and the update is what is actually updating the speeds. And they're going to update the speeds, or we're going to update these speeds by these random integers that will either be increasing or decreasing. So that's the random direction that's been set. And also for all of these space rockets, we want to make sure that they're bounded within the screen, and we do the same thing. We make sure that the bottom of the image isn't too close to the bottom of the screen. So we just make sure that remember, the height of the screen is, we set that to 500 high. So the minute it gets to 490, which is 10 less than 500 height minus 10, we'll just bounce them off in the opposite direction. If it was moving, we're going to bounce it off in the opposite direction. And likewise for the top, if it hits the top of the screen, we're going to bounce it downwards. If you see here, we've done a -2, so and here we've done a +1. So when it bounces off the top of the screen, it's going to go slightly slower than when it's bounced off the bottom of the screen, because we set it to -2. Remember, we could set it to -10 if we wanted, or some other very big number, but it just fly across too quickly. So we don't really do that. And again, the same for the width. If we get to the end of the screen, so if the left-hand component of the rectangle is greater than width, then we're going to say we're going to set the right hand, we're going to make it come back onto the other side of the screen. We're going to set the right hand is equal to 0. And likewise, if the right hand goes too far to the left hand bit of the screen, we're going to set the left hand side of it to equal width, i.e. so the left hand side ends up of the rectangle of the rect which contains our image would end up on the right hand side of the screen. So it looked like the rocket was going off the left hand side of the screen and coming back on from the right hand side of the screen. And that way we don't lose any rockets. Otherwise we'd just be losing rockets, because they would go off the edges, the tops, the bottoms, or the sides of the screen, and they wouldn't come back. So it's just a way of bouncing them back. The next thing we do is set up the drawing window, and this is really where the rendering and everything begins. So we do the screen, we set a value something, and we call it screen. You can call it what you want. Here we set the screen to be pygame.display.set mode, and this is where we set the mode of the width and the height of the screen. So now we've declared our screen, and we declare the clock. And the clock is kind of like the important bit in a way because it represents the refresh times. And here, clock is just set to pygame dot time dot clock. I wonder what if we actually hover over the word clock, if we actually see anything. It says missing module. I don't know why it says missing module. I'd have to look that up. And next we set all sprites to be pygame.sprite.group, which is basically the collection of all of the sprites. So when we do a refresh, we refresh all sprites, we refresh everything in one go. And we stick all of our sprites into a group, effectively into a group. And we initialize a player, which is here. We just say player equals player. So we could write initialize player. And remember, that's as a singleton, there's only going to be one player, which is you or the user in this particular game. And the next thing we do is we make a list of enemies. And this is where we are going to, instead of just initializing the player, we're going to initialize enemy. If you can see here, I've made the enemy class here, and I stick it into an array. So we define enemy with a small e. You can see this one's got a big E. That's the class enemy, and this is just an array, a list of enemies. So I've used a small e for enemy there. It's just a list. And I've just set, let's just say the number of enemies is 5. We set it to an integer of 5. We could make 10 enemies or 20 enemies. We've just set 5 here. And we just say for iron range of number of enemies, so 5 of them in this particular case. We do enemy dot append, and then we add one enemy class into the list, and then we add the second enemy class into the list, and so forth. When we add the first enemy class into the list, we've now got a list of length 1, and its first item its ith item will be 0. So enemy I will be 0 initially. So enemy 0, and we set its rectangle.center. So we're setting the center of the first enemy equal to, and then I've used this function here, which is random.uniform, and that's just get a random number on the range of A to B. And I've just set it somewhere to be a quarter of the way across the screen and anywhere up to 95, because we don't want it to be too close to the bottom. Oh, sorry, it's just the width. So a quarter across the screen, and we don't want it to be too far to the right hand side, so 95% of the right hand side, because if it is right on the right hand side wall, then we just might not see it. We might see half an image or something like that, so we don't want that. So I've just moved it a little bit inwards. And likewise for the height, remember height was 500 high, and again I set the so it's height times by, and then it's random. And we don't want it to, if we set it to 0, it would have started right at the top. But remember, we've got some writing at the top. So I just want to start it 10% of the way below the top, so that we don't have rockets on top of the writing, where we're just describing, like, positions and things, or some other message to the user. And likewise, again, we don't want it to be too close to the bottom, so we don't want it to be 1. So we just moved it to 95% of the screen. So the most it could be down is, if you had 500 pixels as a height, to be 500 times by 0.95, to be 475 pixels down. It wouldn't have used the last 25 pixels at the bottom. And then we do all sprites. And remember, all sprites, if I double click on it, you'll see it just up here. It'll be all sprites, which is pygame.sprite.group. And we're going to add the player, which was this player class. And then all of the enemy classes, 1, 2, 0, 0, 1, 2, 3, and 4. All 5 in this range here, it starts counting from 0 to 4, but that are the 5 elements. So all of these 5 enemies, this list will also be in the all sprites, group, which is a group for the class. Now the next thing we do is we're going to run until the user says that they don't want it to run. And the way that we do this is with this while loop. And we're going to test in the while loop. We're going to test for something called running. And we're going to set running to be a value, to be a Boolean value. And we're going to set it to initially be true. So basically, while this is true, we're going to keep on doing our loops and keep on running. And that means that the game is going to continue. And the other thing here we've got is count crash. Although I actually don't use it, I was using it for testing, but we initialize our variables outside of the loop. And if you can see, we've got this clock.tick, which is the next thing. And remember, we defined this frames per second initially right at the top in our definitions, and we set that to be 30. So it's going to tick 30 frames per second. And we also saw just above that clock was pygame.time.clock. So we're going to effectively create a tick at 30 frames a second. That's what we're going to do. If we set it to a slower amount, the game would become, in a way, a bit more responsive and playable, but then the refresh would happen less often, and the user might see some flickering. So 30 frames per second is roughly the correct amount. We could do more frames per second, but it might heat the processor up of the computer, or we can overclock it as well. So we don't want to do that. We just want to kind of get the right amount, and that is roughly about 30 frames a second. Next, we're going to look for events. So we look for events in PyGame, and the way that is done is doing this, which is for event in pygame.event.get. The pygame.event.get, it won't show it because it's going to say it's a missing module, I guess. For some reason, PyGame doesn't. Let's see if it doesn't even get it. But pygame.event.get gets the events effectively. So any event that happens. So for example, if we press the key down button over here, it's also got a quit button here. So if we actually click on the quit, the top right hand corner where the X button is, that will quit the game. It will set running equal to false and create a quit. But if we press the key down, for example, that's an event. So if event.type equals pygame.keydown, which is we are pressing one of the keys, then it's going to say which key have we pressed. Now, if we press the down arrow key, then it's going to be k_down. That's pygame.keydown. And if we have pressed the down arrow key, we want the y speed to increase plus equal by 1. So we want the y value to keep increasing by an extra 1. And if we press it again, it's going to increase y speed. So y speed will go from 1 to 2. So we're going to accelerate faster the more we press the down arrow. So our rocket will just go down faster and faster and faster as we keep pressing it. The same thing for the k up to make the rocket go up. If you see here, we've used minus equals because we want to take 1 off of the number. So it's going to slow it going down and then increase it going upwards as the number gets more and more negative. So if we were at plus 10 and we pressed the up arrow once, it go to plus 9. So it would still be going down, but less fast. And then if we press the up arrow again, it goes for 8, 7, 6, 5, 4, 3, 2. Then it would stop. It would stop going up, and then it'd be -1, and then -2, -3 would be going up faster. Likewise for k_left, that's to make it move to the left-hand side. And again, remember, if we want it to go leftwards, we want it to be negative. So it's minus equals 1. And if we want it to go right, it's plus equals 1. And I've also put in k_escape. Remember, the escape key is the top left-hand key on the keyboard. So if you press k escape, we've set this running variable, which is what we're checking for while running. We set that to equal to false. So it's not running. So it jumps out of the loop. And if it jumps out of the loop, it effectively does the quit. It's no longer in the loop, so it jumps right out and it does done, time to quit, and it does pygame.quit. It doesn't do any of the other rendering. Now, we're still in the loop here, we're still in that loop, and what we want to do whilst we're running is we want to check for the we create some text. We want to tell our screen where it is for a start. So while it's running, and we've got a text here, and our text is the player.rect.center. So it's the players that we set the enemy 0, so we're looking at the first enemy only, and that's the one that we want to keep hitting each time. So we've got 5 other ones, but we want to keep it. If we don't hit the right one, then it doesn't disappear. We just kind of like pass over the wrong rocket. So if we hit enemy 0, then that one is going to be what we're going to define as a collision. So in the actual string, so in the text string, this is what we're going to write. We're going to look at player.rect.center. We're going to look at the distance between where our player is and where the enemy that we want to chase is. So we're going to look at its x coordinate, which is rect.center 0, which that's the x coordinate. Remember, that's the left hand side of because the rect.center it has got 2 variables. It's got the x component and the y component. So the first element of center 0, so element 0 is the left hand component, and element 1 is the y component, so it's how far the y's are apart. So it's just a string that we're concatenating here for the distance apart on the x component, and then the distance apart on the y component, and we just do this string, and here is the distance, and it's these 2 values, but we encompass it in the string here because if we added a number to a string in Python, it might create an error, so we just turn it into string, and then we add on a comma, and then the y component over there, and again we stick it in as a string for the same reason. If it was a number, it'd create an error. And then when we're actually writing to the screen, again, we have to remember that it's true, so that we write to the screen, and then we use white text on black background. That's what these 3 parameters are. If we did false, it wouldn't write anything, I don't believe. And if we did black on black, we wouldn't see it, for example. So it's white writing, black background. That's what that is. And also on the other text box, I've just defined the text 01, and it just starts off saying number of enemies. We're going to start off with 5 enemies because we set number of enemies earlier up here at the top of line 148 to be 5, so it's 5 enemies. And again, true, white, black, so it's going to be white writing on black background. Now we look for if a collision occurs. And the way that we do it, there's loads of ways of doing it, but here I've just set a collision radius. There's actually a function in pyGame, but I haven't actually used it. But I've just set a collision radius basically, and all I've said is this collision radius. I give it a value of 50, and what we do is we look for if the center of the player less the center of the center of the enemy that we're trying to chase, and we're always trying to chase enemy 0, so we haven't done any of the other enemies. Now I could do enemy 1, 2, 3, 4, and 5, and so we could like let the user check and crash into each one of those. Also, that's the components of it. So it's if the x coordinate of the player is less than subtracted from the x coordinate of the enemy, so if that is less than this defined collision radius of 50, and if the y coordinate of the player is less than the y coordinate of the enemy, remember it's enemy 0, and the center is 1, that's what represents the y coordinate. So here it's got center 0, that's the x coordinate of enemy 0, and this is the y coordinate of enemy 0. So at each point in time, we're just checking that the x and y coordinates of the player less the enemy. So if we're close enough to the enemy on the X component, and we are close enough to the enemy on the Y components, if that's less than collision radius 50, so if we're within 50 on each of those, that we print enemy count crash. We've had a crash number of, we print that just to the screen here, and you actually see where I've done an initial test. It will just show that crash, and then it will show how many enemies are left. And what it will do is it will play a sound, the thwacko2 sound, which is just a little like tuk kind of sound. And then what we do is that you can't actually delete in pyGame. You don't actually delete the rectangles or the surfaces. What you do is they're still around, but what we do is, because I tried to actually delete them with this enemy.pop, like to remove it from the array, that's not helpful. What we actually do is we set the image to black. And then we do, remember, we do the set color key, and that just, if we do set color key and we set the color key of the image to black, if we do that, remember, it will turn whatever we put in the set color key function, will turn it to effectively invisible. So we set it to black and we say black is invisible, and then that enemy, so enemy number 4 is no longer visible. So it's actually moving around the screen, but it's just basically disappeared. So there's no more, we don't see it. So the 5th enemy, number of enemies, remember, it starts off at 5. But it's 5 enemies because we go from 0 to 5, but it's 5 less 1 if you remember from arrays, because array sizes are the length of the array less 1, because we count from 0. So remember, all arrays in Python go from 0 to n minus 1. An array of length n, that its final element is n minus 1. And the final bit basically is we reduce the number of enemies to number of enemies minus 1. So we knock 1 off the enemy's value. And we could have used num enemies minus equals 1, but I've actually just said it here just so it's a little bit clearer to me that number of enemies equals number of enemies minus 1, which means if we had 5 enemies, then we would subtract 1, and then we would therefore have 4 enemies afterwards. And we keep reducing the number of enemies until we've got to no enemies left. And when we do get to no enemies left, we just have to do a little check. So if number of enemies is less than 1, so that means if number of enemies is 0, basically, we want the game to be over. So we've got this other text box, texo2 I call it, and instead of being number of enemies, instead of it being number of enemies and then specifying and how many enemies there are left, what we're actually going to do is we're going to say game over, and then we're going to set running equals to false. And remember, if we set running equals to false while running, if we look at that, if we set that to equal to false, the loop will stop running. We're out of the loop. That's the end of the game, basically. So we do that if statement to just check, and if we have got no enemies left, so enemies are equal to 0, this if statement here becomes true, and we enter into this little piece of code. Now that it's true, we say game over. We say that in white text on a black background, and we set running equals to false, and we jump out of the loop. That's it. The game's finished. Now, if number of enemies isn't 0, so we've still got enemies left. We've reduced our enemies, for example, from 5 to 4, so now we've got 4 enemies. We've had a collision. Because we're in collision, we were in the radius, and we're in this if statement. And what we do, just what I've done for let's call it the fun of the game, is we iterate back round the remaining enemies. So remember, number of enemies would be 4 instead of 5 this time. So we would loop from 0 to 3, representing the 4 enemy numbers: enemy number 0, enemy number 1, enemy number 2, and enemy number 3. That's actually 4 items, 4 enemies in there. and we loop from around them, and we loop in the same way. We just set their centers to equal to the width somewhere like halfway across the screen or something like that, comma 1, so to the end of the screen. It's just setting the enemy positions. In fact, maybe I'll set it to something like 0.25 and 0.95, just setting the enemy positions, and also likewise the heights. And remember, we don't want the heights to be too close to the top and bottom, so I just started them from 0.5 to 0.95. And they're going to be moving in random directions as well. And also we're going to reset their images, so we're going to just again change the game up a bit. So imagine you crashed into the pink. There was a pink rocket, and that was the 0th enemy, and that was the one that you wanted to hit, and you crashed into it. It would just set a bunch of new random colors from the random, using random.choice. Remember, random.choice lets you choose a random element from a non-empty sequence. So it'll be this. It'll be one of these 5 colors. One of these 5 images will be picked, and it's the same thing. And we do the color key white. Remember the backgrounds, we want to turn them in, the backgrounds invisible, so we just have the rockets and not white squares. So we're just looping through, recreating the enemies in random positions that are moving in random directions, and yeah, and they just continue moving, and you've got to go and hit them. Now, as part of the loop, in the while loop, if you can see down here, while running, and if we move down that line, we're still in the actual loop itself, and we've got to do the updates. So we do all sprites.update. That updates all of our sprites. And then we do, redraw the screen. So we do screen.fill dark blue. So we just draw the screen over the last bunch of images effectively. So now we're left with a dark blue, just a dark blue screen. Remember, this all happens at 30 frames per second. The next thing we do is all sprites.draw on the screen. So on that dark blue screen, we're going to draw all the sprites. And remember that the all sprites contains the player and the array of images that are remaining effectively. So if we had like 4 images left, or 3, or enemies, I'll call them enemies rather than images. If we've got 3 enemies left, then it will be the player plus 3 enemies. If you've got 2 enemies left, it'll be the player plus 2 enemies. That's what will get drawn as all sprites. And then the next thing we do is we just write onto our text boxes, and that's just screen.blit.textRect. They're just 2 rectangles that we defined right at the beginning, if you remember, and that's just to write onto the rectangles in our white writing on the black background. So that's all that was. And then pyGame display.flip, and that's what does the flipping of pyGame, and that's it. That's going to keep cycling through and through, and we'll be able to play the game. So again, if I was to hit F5 just to run it, hopefully we see that launch itself. We're seeing the codes initializing, and is it running? Why is it not running? Let me hit stop and run it again. Maybe I jumped out of it. Waiting for the debugger to spawn. Hit cancel. Let's hit F5 again and see what's going on there. Right, there we go. It looks like it's started, and we can see it moving there. I'm not sure why we can't see the top of this screen. Let me see if I can and we can, well, what we can see, if I actually make it bigger, make this much bigger, is we can see our rocket here on the image, and if I move it if I press the left arrow key, we can see the rocket accelerating backwards. And if I press the right arrow key, we can see the rocket accelerating forwards. And what we can see is when the rocket gets to the end of the screen, so if we're at width.max, we're just about to get to width.max, it comes over the other end and it comes out the other side. And let's just get this away. I don't want to crash into the last one too quickly. If we move the rocket upwards, remember we bounce off the top. And if we move the rocket downwards, we bounce off the bottom. And I didn't set it backwards for the image, but if the rocket goes backwards off the screen, what should happen? It actually just disappears because we didn't set a backwards function. So let's get our rocket back. In fact, there we go. We'll end the code. And I'm actually going to go back in here and scroll back up. And what we're actually looking for is where we've got player. So here is our enemy, and we protect the enemy from the top of the screen. We protect it from the bottom of the screen. We look at its right hand side and its left hand side. But on the actual player itself, so for the enemies we've only got 3 if statements, and it should actually be a 4th if statement. And I did actually add a 4th if statement to the enemy, so I just believe that it's going to be that last one, which is if we go off the other side of the screen. So if rectangle self.rectangle.right, so if that's less than 0, then we are going to set the left hand side equal to width, so it will come back onto the right hand side. So I believe that's going to be catered with. I'm just having a little think about that. Yes, because we turn width, if we get to width, we go to 0. So we're checking for if we're less than 0, we're going to go to width. And we'll just see that. I'm just going to rerun the code by hitting F5, and we're going to run the rocket over the left hand side of the screen, and it should pop out of the right hand side of the screen. So again, we can just see our game running here, and I'm going to move the rocket backwards as such, and if it goes, as you see, it hits the left side of the screen, it pops out the right hand side. And let's just try and find the collisions to bump into a rocket. It's not that one by the looks of it. It's that one. I just hit a rocket. Let's do another one. It's not that. Not that. Let's try this blue one here. Nope, not that one. I think we tried the brown one already. It's not that one. So it must be this pink one that's flying across. Yep, it was. Let's try and hit the green one first. Boom, yep, that green one got hit. Let's try and here we hit that one. And then finally this one, it will stop the screen. And that's it. So that's basically the game, and I've called it Sky Dodge. There are other things that you can do. For example, I'm going to try, maybe I'll make that, call it Sky Dodge 5, which is let the rocket fire out a bullet. So the bullet will be another rectangle, another shape, and I'll have an image for the bullet, some sort of rocket looking thing, or like some sort of projectile, or maybe just a dot. And if that hits one of the rockets, for example, then it might eliminate one of the rockets from the game. So we could do something like that as well. And that's really it. That's pyGame. That's a use of pyGame. It's not the most elaborate of games, but it shows enough of the components, some moving images, an array of enemies, effectively. We destroy the enemies one by one in what we might call collisions, and that's a game. We've got some different image colors. We've got sound, although there wasn't much sound that you could hear. You'd only hear the little blips when the rockets were hit. And we got the key presses. I guess that's one of the important components, is how to interact with the keyboard. We've got the key presses, the key ups, the key downs. If we press the escape key, we'd have exited out the code as well. And that's pyGame. So thank you for listening and watching. So Thank you for watching my video. I hope it was helpful. And if you did like it, then please press the thumbs up like button and also press the follow button below. I will have more programming videos and also some trading and math ones to come too. Thank you very much.